Hi everyone. Today we'll be discussing the sum and difference formulas. These are also identities, but before we can do that, we need to recall a few things. The first thing we need to recall is the exact value chart. So let's go ahead and make that. The way we would make that is 1, 2, 3, 3, 2, 1. Everything over 2. Everything on top gets a radical except for the 1. And the bottom is just rad 3 over 3, 1, and rad 3. And how we get those values is just doing 1 divided by rad 3 and rationalizing it. Rad 2 over rad 2 is 1. Rad 3 over 1 is rad 3. Remember that tangent is sine over cosine, so I just divided them. Okay. So these are new right here. These are functions of sum of two angles and functions of difference of two angles. We're not going to prove the formulas, but we're going to use them. So let's look about what they ask. So for question 1, it says evaluate sine of 60 plus 30. So we know that, just recall that 60 plus 30 we know is 90. So do we know what sine of 90 is? Well, if we make a little tiny unit circle over here, 90 degrees is up here. This is the point 0, 1. And sine is the y value. So what is sine of 90? Sine of 90 should give us 1. So let's see if we use the formula right here for sine of a plus b. A would be 30, b would be 60. Let's see if we get, in fact, 1. So let's first start by deciding which one is a and which one is b. So obviously this would be a and this would be b. So let's write down this top formula. Why did I use this formula? Because I'm using sine. Sine 30 plus 60 would be a plus b. So let's write the formula. Sine, let's write it a plus b equals sine a cos b plus cos a sine b. Now instead of a and b, let's use the 30 and 60. So we want to write sine of 30 plus 60. So sine of 30, since a is 30, cosine of 60, since b is 60, plus cosine of a, where a is 30, so cosine of 30, and then sine of b, where b is 60. Okay, so if we use our exact value chart up here that we just made, we can fill in sine of 30, cos of 60. So sine of 30 is 1/2, and we're going to put this in parentheses because we're going to need to multiply this by cosine of 60, which again, if you look at the chart, is 1/2, plus cosine of 30, if you look at the chart, is rad 3 over 2, and sine of 60, if you look at the chart, is rad 3 over 2. So let's simplify this a little bit. What is 1/2 times 1/2? Multiply tops, you get 1. Multiply bottoms, you get 4. Plus rad 9, remember, inside times inside, over 4. And isn't rad 9 3? So aren't I doing 1/4 plus 3/4? Same denominator. Keep the denominator, add the tops. So 4 over 4 is 1. So we just proved how it's the same thing as if we just used the unit circle. Okay, so now let's look at example number 2. Example 2 has this long sine 50, cos 20 expression here. So you basically want to match up to see which one is it out of these 4. So let's see, sine of 50, so sine cos minus cosine. So sine cos minus cosine. So I'm thinking it's sine a minus b formula. So let's go ahead and write down that formula. So sine a minus b. Now we don't even need to write the rest of it because we know that it's going to be this stuff over here. So can't this be a and this be b? And can't we just plug that into here? So this would be sine of 50 minus 20. And doesn't 50 minus 20 equal 30? So now all we need to do is find sine of 30, look at the exact value chart, and you get 1/2. Okay, let's let's do the next problem. Okay, so the expression cos plus sine. So now we're going to look on the back page again, the front page, and see where I have cos plus sine. So take a minute, pause the video, and see where you can find it. Okay, so if you look, you found cos plus sine. I believe that one was cos A minus B. So again, here's my A, here's my B, and we did cosine of A minus B. What's A? Nothing but 4x. So this is the same thing as cos 4x, and B is 3x. So 4x minus 3x is just x. So that simplifies to cos x. Choice C. Okay, number 4. Find the exact value of sine 75. So now, when I have exact value here, I know I have to use the exact value chart somehow. And on the exact value chart, all I have are 30, 45, and 60. I don't have 75 anywhere. But could I add, say, 2 of these, or subtract 2 of these to get 75? I'm thinking we can add 30 and 45. So therefore, we would write that sine of 75 is equal to sine of 30 plus 45. Because again, the 30 plus 45 gives me 75. So let's write down the sine A plus B formula. So sine A plus B equals sine A cos B plus cos A sine B. And remember, A is 30 and B is 45. So we want to find sine of 30 plus 45. Sine of 30 is A. Cosine of B, B is 45. Plus cosine of A, where A is 30. Sine of 45, where B is 45. So, again, looking at the exact value chart, we see that sine of 30 is a half. Cosine of 45 is rad 2 over 2. Cosine of 30, we know, is rad 3 over 2. And sine of 45 is rad 2 over 2. So now again, let's multiply the first two together. Tops times tops, bottoms times bottoms. So rad 2 over 4 plus rad 6 over 4. Again, the denominators are the same. So what do I do with those? Keep them. And what do I do with the tops? Add them. So this is my final answer. I didn't make rad 2 plus rad 6 rad 8 because they're not like numbers under the radical. Remember, you can't add radicals unless the number under the radical is the same. So that's why this is the final answer. Okay. Why don't you try number 5 for homework? But let me set you up for it in the meantime. So again, we need to rewrite cosine of 15, or in other words, we need to rewrite 15 in terms of the exact value. So the 30, the 45, and the 60. Clearly I can't add any of the two because they'll be bigger than 15. So which two do I subtract? Well, I really could subtract 45 and 30, or I could subtract 60 and 45 and I would still get 15. So let's, for argument's sake, let's all do the same one. So let's do cosine of 60 minus 45. So I'd like you to try this at home. I'd like you to say that cosine of the 60 minus 45, write down the formula, and then make this A and this B, and come up with an answer, and we'll check it in class tomorrow. Okay, let's go on to the next page. Okay, so number 5, it says if A and B are positive acute angles. What does that mean, positive acute angles? Acute meaning less than 90 degrees, and positive meaning positive. So this has got to be an angle in quadrant 1. So there's 2 different angles that we're talking about here. So we really should have 2 different pictures. So let's draw 2 triangles from quadrant 1. And we'll put A in here. This is A. Let's draw another one. Quadrant 1. We'll put B in here. Okay, now remember, we've got so, ka, and toa. We'll stop there. So sine is 5 over 13, or O over H. That means with respect to angle A, the opposite side is going to be labeled with a 5. The adjacent side, I'm sorry, not the adjacent, the hypotenuse side will be labeled with a 13. Okay, now let's look with respect to angle B. We've got 4 over 5, or A over H, adjacent over hypotenuse. So with respect to B, where's the adjacent side? Right here. So we'll put a 4 there. Where's the hypotenuse? Right here, which we'll call 5. Now, the way you find the missing pieces, this piece and this piece of these right triangles, would be to use the Pythagorean theorem, or you can know the triplets. So the triplets tell me that this side is 3 and that this side is 12, and I'm going to use that information. So the question is asking me to find sine of A plus B. So what we're going to do is write down the sine of A plus B formula like we have been all along. So sine of A plus B is equal to sine A cos B plus cos A sine B. Okay, so the first part of the problem asks me to find sine of A. So that means we have to draw our attention over here to angle A. So sine we know is opposite over hypotenuse. So 5 over 13. So we can put that here. Now they want cosine of B. Here's B. And we want to know what cosine of B would be. And we know that it is adjacent 4 over hypotenuse 5 plus. Now they want cosine of A, so we have to look at this triangle. So cosine of A would be adjacent, which is 12, over hypotenuse, which is 13. So let's go ahead and put 12 over 13 for cosine of A. And then the last thing that we want to do is find sine of B. So here's B, sine, opposite, 3, hypotenuse, 5. So 3 over 5. So now all you have to do is put this whole thing into the calculator, get an answer, math enter, enter, and you're good to go. Alright, hit pause, and then you'll find the answer when you're finished. Your answer should be 56 over 65. Final answer. Okay, let's move on to example number 6. So example number 6 tells you we've got, again, two different triangles. We've got sine of A and cos of B. So we need two different pictures. One for angle A and one for angle B. But we have to keep reading to find out where they go. This says A is between 0 and pi over 2. Remember, pi over 2 is 90 and 0 is 0. So between 0 and pi over 2 is 90 degrees. So that means triangle A is in quadrant 1. What does it say about angle B? Angle B is between pi, which is 180, and 3 pi over 2, which is 270. So pi would be 180, like we said, and right over here, and 3 pi over 2 would be here. So it's got to be in quadrant 3. So remember the bow tie. We draw the triangle like this, and here would be B. Now let's label it where everything should go. So sine of A is 3 over 5. Opposite, 3. Hypotenuse 5. So we can go ahead and just put the 4 here because we know that that's the Pythagorean triple. And it says that cosine of B is negative 12 over 13. Disregard the negative. The only thing that the negative means is that cosine is negative here. Why is cosine negative? Because tangent is the only thing that's positive. So that'll come into play later. Okay, so cosine, again, is 12 over 13. So adjacent, which is 12, over hypotenuse, which is 13. And from the Pythagorean triple, you can remember that that side is 5. So they want us to find two things. They want us to find cos A plus B and tan A minus B. So let's do cos A plus B first by writing down the formula. So cos A plus B equals cos A cos B minus sine A sine B. So cosine of A is adjacent, which is 4, over hypotenuse, which is 5. cosine of b is adjacent, which is 12, over hypotenuse, which is 13. But notice, I put a negative. Why did I put a negative? Not because it was given here, but because in quadrant 3, tangent's the only thing that's positive, therefore cosine is negative. Why did I leave cosine of A to be positive? Because this triangle for A is in quadrant 1, where everything is positive. Okay, let's move on. Sine of A. So sine is opposite, which is 3, over hypotenuse, which is 5. So 3 over 5. And sine of b, now we're going to look in this triangle, is opposite, which is 5, over 13, which is my hypotenuse. So 5 over 13. But is sine positive or negative in this quadrant? You should be saying negative. So that gets a negative. So if you put this into the calculator, this whole entire piece right here, just the way you see it, you should get negative 33 over 65. Please check to see that you got that. And then as a homework exercise, please do tangent of A minus B. Use the formula on the front page, and we'll go over it tomorrow. All right, we're all set. Bye-bye.